Alright, good afternoon and welcome to Master Talker online class. Today we'll be solving this function question. They said let A be a set of this, okay, and Z is equal to set of integers. Then let F such that A map to Z, okay, be defined by F of X, which is equal to this. Let me say that this thing is equal to set B, okay. Then let's find the domain, the range, the codomain, the primitive, and the rest of them. Now the domain, number one, the domain. I told you that domain is simply, let me call it D of F. Domain is simply what we are using to work, and what we are using to work is -3, 2, and 1. This is what we are using to work. Then let me get the primitive. Primitive is the domain that you are not putting in set, which is -3, 2, and 1. Okay, this is the primitive. This is IV. II. Now the codomain is the all the necessary things you need to get, which is the larger set, which is the set of what? Integers. If this maps to set of integers, so the codomain. The codomain is what? Is the set of what? Integers. The codomain is the set of integers. Okay. Then III is what? The range. Okay, III is the codomain. II is the range. The range is that set B, which is all the possible things you can get from here. So let's put -3. Let's put it here now. F of -3. F of -3 is equal to 2 into -3 minus 1, which is what? -6 minus 1 minus 7. So the first one is -7, comma. The next one is 2. F of 2. F of 2 is simply what? 2 into 2 minus 1, which is what? 3. 2 times 2, 4. 4 minus 1 is 3. So I'm having 3, comma. The next one is 1. So if I put 1 here, 2 times 1, 2 minus 1 is 1. So this is what? This is the range. So the image or the image or the ancestor, which is V, okay, the ancestor is something as the image. The ancestor the ancestor is the range that you did not put in a set, which is -7, 3, and 1, which is something as the image. The same thing as the image. So the next one we're going to solve is VI. Is it a function? Function is what? When you have one person producing 1. Whenever you have 1 at the end, one person producing 1, or many people producing 1. So that is, let me just draw this thing and see how it looks like. This is my A. This is 3, 2, and 1. Sorry, -3, 2, and 1. So I'm having B, and B gave us -7, 3, and 1. So this produces this, this produces this, this produces this, and this one to this, and this is the function. So this is a function because 1 producing 1 is a function. So it is a function. So what type of function? Is it identical? No, because this is not producing this. Is it 1-to-1? Yes, it's 1-to-1. It's a 1-to-1 function. Is it equally onto? Yes, because is it equally onto? No, it is not an onto function because the codomain is what? Z, while the range is what? Just these 3 things. So it is not an onto function. So it is only 1-to-1. Is it identical? No. So it's only 1-to-1 function. So we have answered this question, and this is your past question. Okay. So the next one we are going to look at . Okay. The next question we are going to look at is now whenever the thing has a denominator, let me give anyone that has a denominator. okay, they said I should find A, the domain, B, range, C, codomain, okay, if f of x is equal to x over x minus 1, where x is an element of a real number. Okay, so in this one they've told you where the codomain is going to. In fact, the first thing I'm telling them is that the codomain is the R, which is the larger set. Yes, the codomain is the R. Then let's find the domain. In this type of set, finding domain is simply equating the denominator to be 0. Okay, equate the denominator to be 0. So to find the codomain here, you say x minus 1 is equal to 0, because they don't give us where we are working from. So let's get where we are going to work from. So I'm having that this, so x is equal to what? 1. So if you put 1 in the denominator here, it's going to make this thing undefined. So 1 is the only problem. We are not going to work with 1. We are going to work with every other thing but not 1. So what do we say now? That the codomain, the domain, anything we are going to work with is what? That real number, removing what? Just 1 that will not work. This one will not work. So these are the things we can use to do that. So now the range, this is the domain A. So the range is the possible answers we are going to get. So the possible answers we are going to get, even if we put, you'll be checking 3 things. For the real number, you check the negative real number, you check 0, and then you check the positive real number. This is how to get our code, our range, please. The result. Let's check positive whole number. Let's check any negative real number. Let me say from minus 1. If I say minus 1, minus 1, if I put minus 1 here, it's giving me number. So if I increase, it's still giving me number. So I think that this will work. Plus, or you know me, plus. If I put 0, will it work? Okay, sorry. We are checking what we are going to get. Are we going to get a negative? Is there something that we can put here so we can get a negative real number? So let me check. If I put that x is minus, if I put that x is minus 5, if I put that x is minus 5, if I put that x is minus, let me take minus 1, for instance. Minus 1 over minus 1 minus 1, which will give me minus 1 over minus 2, which is what? 1 over 2. This is not negative. Okay? Let me put 0. If I put 0, 0 all over 0 minus 1, which is what? 0 over minus 1, which is 0. Is there any way we can get negative? There is no way we can get negative. Even if I use 1 will not even work at all, because it's giving me negative infinity. So this is not these are the things we are checking. So this person is out of it. This is out of it. So is there any way we can get 0 here? Yes, we can say get 0 if we put 0. So 0 is part of my answer. 0 is part of my answer. Union. Is there anything that can give us positive here? Yes, we can get positive here. But is there any way we can get 1? Is there anything that we can put here so that there will be the same thing that cancel out to get 1? It's not possible. So, but can we get other positive? Yes, we can get other positive. If I put 2 here, 2 minus 2, so I'm getting 2. So we can get other positive, but we cannot get 1. We cannot get 1 as an answer. So my answer is 0 union real number, then minus 1. Okay? So that is my codomain. Sorry, my domain. My range, rather. My range. So let me check if it's correct. Is there anything that can give us negative here? Let's check half. Half here. Half. Oh, yes. We can get negative real number. We can get negative real number. We can get negative real number. If we put half, if we put anything that is close to 1 but it's not 1, we can get positive real number. So if you combine these three things, it means real number. So it's just real number minus 1 because we can never get 1. So this is my code, my range. So that is that. Is this a function? Yes, because there is no way you can get two things. Is it identical? No. Is it onto? No, because the codomain is not equal to the range. The range and the codomain are not the same. So it is not an onto. Is it 1 to 1? Yes, it's 1 to 1. So that is that for that. So the next thing I'm going to teach you. The next thing I'm going to teach you, let me increase my voice because of the mic. Okay, the next thing I'm going to teach you is let's look into other types of function. But before that, there is this type of question that always comes out. The question says, let f of x be equal to 2x plus 1, comma, g of x be equal to s squared plus 1. Then I say find g of f of x. A number 1 question. Number 2 question. Find f of g of x. Number 2. Number 3 question. Find f of g. In fact, they can write it like this: f of g of f of 1. Okay. Number 4 question. Find g of g of f of g of minus 1. Okay. Solution. This is very simple. This is very simple. The first thing is what? F of x. F of x means in that f of x, anywhere you see s, put the same thing here. So I'm getting the same result, 2s plus 1. So now g of f of x means anywhere you see x in g now, put this answer, put this thing that is inside here, put this f of s, and this is f of s. So let's go. This is x, so I'm going to say 2s plus 1 all squared, then plus 1. Anywhere you see x, replace it with this thing. So my answer is now square the first one, 4x squared plus 4x plus 1 plus this one, which is what? 4x squared plus 4x plus 2. Okay, you are done with that. Number 1. Number 2. Number 2 said f of g of x. So first thing we are going is g of x. G of x will give me x squared plus 1. But f of g of x means anywhere you see x here, then put that g of x. So I'm having 2 into x squared plus 1, then plus 1. So what do I have? 2x squared plus 2 plus 1, which is what? 2x squared plus 3. As simple as that. So the next one, number 3. Number 3 said f of g of f of 1. So we are starting from here. First thing is f of 1. F of 1 said anywhere you see s, put 1, which is 2 bracket 1 plus 1, which is what? 3. The next one is g of that f of 1. G of that your answer instead. G of your answer is the next one, which is what? Let's put it 3 squared plus 1, which is what? 10. And the last one is what? F of your last answer, which is what? 2 bracket 10 plus 1, which is what? 21. So the next one, which is the last one, is number 4, is g of f of g of minus 1. So we are starting with g of minus 1. G of minus 1 says what? Minus 1 squared plus 1, which is what? 1 plus 1, 2. So the next one is what? F of that answer 2, which is what? F of 2 is 2 bracket 2 plus 1, which is what? 5. The next one is another f of 5, which is what? 2 bracket 5 plus 1, which is what? 11. The next one is g of that 11, which is what? 11 squared plus 1, which is 1, 2, 1 plus 1, 1, 2, 2. The last one is g of 1, 2, 2, which is what? 1, 2, 2 squared plus 1. So if you get that answer, that is your final answer. So the next thing we are going to talk about is other types of function. Other types of function. Other ones. other types of function. Or before that, there's another question they can ask. Example, they said if y if f of x is equal to 3x plus 3 over 2, something like this, okay? Then they now say find f inverse of x. So inverse of this function, how do you find this in solution? Just say let y be equal to that thing given to you, 3x plus 3 over 2. Then make x subject. You have said let y be this, so make x subject of the formula. If you make x subject of the formula, I'm going to have y is equal to 3x plus LCM is 2. I have 6x plus 3. So cross multiply to have 2y is equal to 6x plus 3. So I'm going to have 2y minus 3 is equal to 6x. So x is equal to what? 2y minus 3 all over what? 6. So inverse of x is anywhere you see y now, change it to x, which is what? 2x minus 3 over 6. So that, which is something as saying 2x over 6 minus 3 over 6, which is what? Here will give you 1 over 3x minus 1 over 2. So any of the two is your answer. Just say let it be equal to y, then find the value of x, make x subject, and that's all. So now let's go to types of function. Other types of function. There are other types of function. Remember the other one we did though. So other types of function. Other types of function. So for other types of function, we have even function, odd function, and the rest of them. So let us do that. Other types of function. The first one we're having is a linear function. Linear function. Now, how do you know that a function is linear? We know that a function is linear if, okay, we know that a function is linear if f alpha x, alpha x plus beta y, is equal to, when you separate it, alpha x plus what? Beta y. I think that is the. Is that? Oh, sorry. When you separate it this way, when you separate it, the alpha first, alpha f of x plus beta f of y. Please, when you separate it, that is when you now know if it's a linear function or not. An example to that said, check if f of x, which is equal to 3x, is a linear function. So the first thing we do is okay, so the first thing we do is what? They gave us that f of x is equal to what? 3x. So now f of alpha x plus beta y says what? Anywhere you see x, just put alpha x plus beta y. So I have 3 into alpha x plus what? Beta y. If I clear, I'm going to have this time this 3 alpha x plus what? 3 beta y. This is the result I got. So now let us check this one. Let us check alpha f of x plus beta f of y. Okay, so what does it mean? From here, anywhere you see x, just put so this is what? Alpha f of x is already what? 3x plus beta f of y will be what? Just anywhere you see x, put y, 3y. So if you have this time, I'm having 3 alpha x plus what? 3 beta y. Are they the same thing? Yes. Once they are the same thing, you now say since alpha x plus beta y is something as saying alpha f of x plus beta f of y, then it is a linear function. It's a linear function. So that is that. So it's a linear what? Function. So now if x now and y are 1, if alpha and beta are 1, you now call it what? I think we call it additive. If alpha and beta are 1, you call it what? Additive. So that is number one, linear function. Please note that formula. Linear function said that f of alpha x plus beta y should be equal to when you separate them. So the next function we are going to talk about, okay, let me give one more example. One more example is f of x, which is equal to x squared, a linear function. So let's check that. We want to check that f of what? Alpha x plus beta y will give us alpha f of x plus beta f of y. That is all. That is how to check. So let us check this one. Alpha f of x means anywhere you see x, just carry this thing inside and put. So I'm having what? Alpha x plus, for this one, for f of alpha x plus beta y should be equal to what? Alpha x plus beta y all squared. Is it not? Anywhere you see x, just put this thing you are seeing. So if I clear, I'm going to have this squared. Square the first one, multiply the first one and second one, double it, square the last one. So I have gotten this. So let me get this one. Let me get this one now. Alpha f of x plus beta f of y. So let's check this one. For alpha f of x, just leave your alpha. And my f of x is x squared plus, just leave my beta. And my f of y should be y squared. So is this thing equal to this? No. So therefore, it is not what? A linear function. Therefore, it is not a linear function. It is not a linear function. If you look at it, you see that that thing is quadratic. So it is not a linear what? A linear function. So the next thing we are going to do, the next type of function is even function. Even function. Number 2, even function. Now, how do you know that a function is even? A function is even if you have f of minus x, it's still giving you f of x. That is when it is even. But if it's not so, then it is not an even what? Function. If it is not so, then it is not an even function. It is not an odd function. No. If it is not so, it will not be odd. It will be what? Non-even. For odd functions say that f of minus x is giving me minus f of x. That is when it will become odd, please. Not that if it is not so, you will not call it odd, please. Oh. So if it's not so, just call it not even. If this one is not so, call it what? Not odd. So let me give you an example. Let me give an example to that. Okay. Now, first example said is f of x, which is equal to x to the power 3 plus x, even. Is it even? Let us check. First thing we are checking is f of minus x, which is what? Minus x raised to the power 3 plus minus x, which is what? This raised to the power, this is giving me x raised to the power 3 with minus here, then minus x. Is this thing equal to this f of x? No, this is not equal to f of x. Therefore, it is what? Not even. Therefore, f of x, which is equal to x raised to the power 3 plus x, is not even. That doesn't make it odd. But let's check if it is odd. Let's check if it is odd. If you want to check if it is odd, first thing you are checking is f of minus x, which is what? F of minus x, which gave us minus x raised to the power what? 3 plus minus x, which gave us minus x raised to the power 3 minus x. Now let's check minus of f of x like this, which is what? Minus before you now put f of x, which is s3 plus x like this. Minus before you now put f of x, which will give you what? Minus s cubed plus x. You see, minus x. You see, so since f of minus x is equal to minus f of x, therefore f of x is what? An odd function. So what made it odd was because I checked it, not because this one doesn't work. Okay, so that is how to know even and odd function. Even and odd function. So I think that is that for now. So in our next class, we now talk about limit of a function. Limit of a function. Where does the limit head to? Now the next type of function is integer or step function. Yes, let me not forget that one, number 4. But they don't normally ask that one anyways. Integer or what? Or step function. Integer. Number 4 is integer or step function. Now for integer or step function says that okay, they say that an integer function, we represent it with this type of bracket, okay, is equal to a set of x. It is x, comma, if x is what? An integer. Okay, if it's a whole number, then that is your answer. But if it is not a whole number, if it is k, which is an element of z, okay, it is k, which is an element of s. It is another whole number, which is an element of s. But it has to this thing, that if x is not integer, comma, where k is greater than that x, okay, or not exceeding x, or last integer before the x, or last integer before the x. Let me explain what they mean here. If I have this, now the integer function of 3 is just 3, is the whole number, number 1. I will solve with example so you understand. The integer function of 6.01 is a number that is in between. No, this one is not a whole number now, so it's in between so we're going to have that this thing is in between two integers, and the two integers is in between is what? 6 is less than this man. It's less than this man. Sorry, 6 is less than this man, but this man is equally less than 7. So we are not going to use something that is greater than him, but something that is very close to him. So 6 is my answer. 6. Look at another one. Minus. Okay, look at another one. 0.03. Look at another one. Let's put it. 1 is less than 0.0. Sorry, 1 is greater than 0.03. Okay, and 0. In fact, let me see. Let me use 0. Yes, 0 is a whole number. 0 is less than 0.03, which is equal less than 1. So which one are we taking? We are taking that 0 as our answer. So the answer becomes what? 0. So you are taking the less whole number. The less whole number. So what do we use now? Look at the next one. IV said minus 6.9. Look at this. So minus 7 is less than minus 6.9, which is less than minus 6. So which one are you taking now? Minus 7, which is the less number. So that is that. I think we are okay for this. Thank you very much for watching. I really appreciate. God bless you. Stay tuned to limits of a function.